what is our first question? It is sodium carboxylic acid salt. Its aqueous solution is subjected to electrolysis. Due to electrolysis between carbon bond gas dissociation, it will convert into free radicals. Two free radicals are present within the molecule. Therefore, between two free radicals, bond formation takes place. This is compound A, right? This is cyclooctane. This is only compound A. Now this compound A is treated with it is borohydride. Here boron is connected to only one hydrogen. Okay, we know it is hydroboration, oxidation, right? First step is hydroboration, and with hydrogen peroxide and alkali, it is oxidation step. Due to hydroboration oxidation, one pi bond get dissociation on one carbon hydrogen and another carbon OH attacking takes place, but it is enol. Enol participate in tautomerism. It will convert into cyclooctanone. This is compound B. Enol convert into keto form. This is compound B. Now this compound is treated with zinc amalgam and HCl. This is Clemmensen reduction. In Clemmensen reduction, keto group convert into hydrocarbon. But instead of this HCl, I have given DCl, right? Therefore, instead of hydrogen atoms here, deuterium attacking takes place. CD2 will get CD2 at this position. Okay, this is compound C. Now compound A is treated with hydrogen palladium barium sulfate. We know this is Lindlar's catalyst. In Lindlar's catalyst, alkyne convert into cis alkene. We are getting cis cyclooctene. This is compound D. This is cis isomer. Next one, this molecule is treated with sodium and ND3. It is nothing but metal and liquid ammonia only. We know one thing, it is Birch reduction. In Birch reduction, alkyne convert into transalkene. Here hydrogen, both are present in opposite side. It is not on same side. Okay, it is 2D molecule. Okay, but actually kaise rahega? This is a trans molecule. Next one is this compound A is treated with BD3, means on one pi bond get dissociation, on one carbon deuterium and another carbon boron attacking takes place. But in the next step, it is treated with CS3CO2. Therefore, instead of boron, we'll get deuterium. We are getting DD only. And hydroboration, it is syn addition, therefore this is also cis alkene only. This is compound F. Now this molecule is treated with bromine in the presence of CCl4. The compound A treated with bromine in presence of CCl4. What will happen? One pi bond get dissociation. Here bromine attacking takes place. But we know addition, bromination is anti-addition. Matlab two bromine atoms are present in opposite side. This is also trans. Okay, this is about reaction sequence. Now the question is, I have given two questions. One is select chiral isomers from following. Which is chiral isomer? Let's check compound D. What is compound D? This is compound D. This is cis isomer. It has plane of symmetry. It has plane of symmetry. Therefore, this is achiral. Achiral is nothing but optically inactive. Next one I have given compound E. Okay, this is compound E. This is trans isomer. Now one thing, we can do one thing here. Here it is cis isomer. It is cis isomer. Cis isomer has plane of symmetry like this. Therefore, this is achiral molecule. Achiral is nothing but optically inactive. Now it's a trans isomer. What is the structure of trans isomer? This is trans isomer. It has no plane of symmetry, no center of symmetry. Therefore, this is optically active molecule. This is chiral molecule. This is trans molecule. Trans molecule is optically active molecule. It is trans molecule. Trans molecule has no plane of symmetry and center of symmetry. This is optically active molecule. Therefore, compound D, it is cis isomer. Therefore, this is optically inactive molecule. Next one is compound E. This is trans molecule. Trans molecule is optically active molecule. This is chiral. Next one is compound F. This is cis isomer. Cis isomer is also has plane of symmetry. Therefore, this is optically inactive molecule. This is nothing but achiral molecule. Next one is compound G. This is compound G. This is trans isomer. A trans isomer is free from plane of symmetry and center of symmetry. Therefore, this is optically active molecule. Optically active molecule is called as chiral molecule. Right? Okay, now second one is about second reaction. It is alkyl fluoride. It is treated with alcoholic OH. We know alcoholic OH is a strong base. It favors E2 mechanism or E1CB. But for condition for E1CB, there must be a bad leaving group. Of course, fluorine is a bad leaving group. And second important condition is beta carbon must be with electron withdrawing group, but there is no electron withdrawing group. Therefore, no question about E1CB. Therefore, the mechanism is E2 only. In E2 mechanism, as there is a bad leaving group. One more important thing is in elimination reactions, there are two rules. One is Sadjeff, next one is Hoffman. But generally, Sadjeff is major product. But in this case, Hoffman is major. What is the reason? Fluorine is bad leaving group. Fluorine is bad leaving group. Therefore, it produces Hoffman product. as major product. This is compound A. Now this molecule is treated with NBS. We know one thing, NBS is for allylic and benzylic halogenation. This is benzylic position, hydrogen will be replaced by bromine. Therefore, this is compound B. Next, it is treated with again alcoholic OH, which is a strong base. Here E2 reaction, dehydrohalogenation takes place. Means from this carbon bromine take elimination, from adjacent carbon atom, from this carbon atom hydrogen take part in elimination, will get conjugated ion. This is compound C. Now compound C is treated with bromine. Now the question is, this is 1,3 butadiene. Now it is treated with bromine. What will happen? It converts into halonium intermediate. It can now what will happen? This bromine carbon bond get dissociation. Br minus can attack on this carbon. This is 1,2 addition. Now pi bond can participate in simultaneous resonance and Br minus can attack on this carbon. This is 1,4 addition. Why is it called as 1,2 and 1,4? Just in a simple method. Let's say this is first atom, it is second atom, third atom, fourth atom. On this first atom, bromine is present already. Here Br minus is attacking on second carbon. Then it is called as 1,2 addition. If Br is attacking on this fourth position, then it is called as 1,4th addition. And we know one thing, at low temperature 1,2 addition is a major, but at a high temperature is nothing but just here room temperature is sufficient. Here temperature is not mentioned, therefore we have to consider as room temperature. At room temperature 1,4 addition is a major, therefore we'll get product like this. Here it is bromine and it is also bromine. Now this is compound D. It is 1,4 addition only, just. It is just only 1,4 addition. What about the next one? What about next one in this case? Now this molecule is treated with. Now this molecule is treated with it is sodium, right? Sodium in presence of diethyl ether. It is treated with sodium in presence of diethyl ether. It is alkyl halide treated with sodium, and it is a sufficient head. It is Woods reaction. And we know one thing, Woods reaction takes place through formation of free radicals. Between carbon bromine bond get dissociation. Between carbon bromine bond get dissociation. Here it is free radical. Here is pi bond. Here it is free radical. Here what will happen? This pi bond participate in resonance. Therefore, we'll get product like this. This is compound E. Now the question is, what is IUPAC name of compound E? This is compound E. This is first one, second one, third one, and fourth one. 4 carbons are present in the main chain, but more than one double bond, therefore buta. At 1 and 3rd position, double bond is present, therefore 1,3 diene. This is IUPAC name of this compound E. Right? What about the next one? It is third question. It is methyl cyclohexane treated with bromine in presence of sunlight. It is photohalogenation, and we know one thing, bromination is a highly selective reaction. Highly selective means bromination takes place at mainly 3-degree position. If there is no 3-degree, and then secondary, and then primary hydrogen. Okay. Therefore, your tertiary product is major product. What about the next one? This molecule is treated with. Okay, this is compound A. Now it is treated with alkoxide. It is ethoxide in the presence of ethyl alcohol. It is a strong base, therefore this is elimination reaction. Bromine is good leaving group, therefore no question about E1CB, and mechanism is only E2. In E2 mechanism, Sergeff and Hoffman is possible. As bromine is good leaving group, here Sergeff is major. Okay, this is compound B. What about the next one? It is treated with NBS. What is NBS? It is N-bromosuccinimide. Allylic and benzylic halogenation takes place. Okay, this is compound C. Next one, it is treated with alcoholic KOH. Alcoholic KOH is a strong base. It favor elimination reaction. Okay, this is compound D. Now compound D treated with bromine. Here it is conjugated diene. Therefore, again 1,2 addition, 1,4 addition, both are possible at low temperature. That is -20, -40 degrees centigrade temperature. 1,2 addition is measured, but it is temperature is not mentioned. Therefore, we have to consider as room temperature. At room temperature, 1,4 addition is measured. Therefore, what will happen? At first position bromine and fourth position bromine attacking takes place, and there will be pi bond at this position. This is compound E. Now, this compound B is also treated with bromine water. Therefore, what will happen? Halon mayan intermediate will be formed, right? Next one is water molecule is nucleophile. Attack on higher degree carbon. Because this is secondary carbon and it is tertiary carbon. On tertiary carbon, positive charge is more stable. Therefore, here bromine attract electron from this tertiary preferential. Therefore, water molecule attack on this carbon, oxygen gets positive charge. Oxygen releases H plus. Therefore, on this carbon, OH and bromine will present. Okay, this is compound F. Okay. Next one more important thing is this bromine may be present on front side or back side. Therefore, we will get here two products, front side as well as back side both. Therefore, we will get here two products. Now, plane of symmetry, now center of symmetry, optically active molecule. This is only racemic mixture. Okay, this is major product only. What about the next one? This molecule is treated with NBS and water. Compound B treated with NBS and water. Remember very clearly, NBS and water is equal to bromine and water. NBS and water is equal to bromine and water. Therefore, paper compound G is also equal to F only. Paper OH and bromine. This is compound G, and this is also racemic mixture. Okay, now this molecule is treated with compound A, B, of course. Compound B treated with bromine in presence of methyl alcohol. We know one thing, methyl alcohol is a nucleophilic solvent. First of all, bromine react with alkene. Halon mayan intermediate will be formed. After that, nucleophile attack on this halon mayan intermediate. Oxygen donating electron gets positive charge, releases H plus. Here this is compound H. Here also same to same racemic mixture. Next one, compound D is treated with this is compound D. Compound D treated with NBS. NBS is for allylic and benzylic halogenation. For bromine attacking. Next one, it is treated with alcoholic KOH. Alcoholic KOH is nothing but a strong base. Alcoholic OH is a strong base. It favor only elimination reaction. Dehydrohalogenation takes place. We are getting methylbenzene. This is compound J. Sorry, this is compound I. No. Not I. It is after alcoholic OH. This is actually, this bromine product is I product, right? Okay, this is compound I. Now this compound is treated with alcoholic OH. After treatment with alcoholic OH, benzene formation takes place. Okay, methylbenzene, it is toluene. Now this compound is treated with KMnO4 and water, basic medium and heating. So that क्या होगा? This is alkyl benzene with benzylic hydrogen. Therefore, benzoic acid formation takes place. Of course, because of our base, we are getting benzoic acid salt. In last step, we are using H3O plus. Therefore, O minus will take H plus converted to OH only just. Okay. This is compound L. But what is my question? From this compound, I want to get this compound L. इनके लिए reagent K चाहिए. What is compound K? Of course, it is not possible in a single step. This is cyclohexene, methyl cyclohexene. It is subjected to heating with nickel or platinum or palladium or sulfur or selenium. Then what will happen? Dehydrogenation takes place, convert into methylbenzene, which is nothing but toluene. Now from this we can take potassium permanganate or we can take potassium dichromate. That is your choice. Followed by heating, then it will convert into benzoic acid only. Therefore, reagent K is mixture of two reagents. One is, it may be nickel, platinum, palladium, sulfur and selenium, followed by heating. And second reagent is potassium dichromate, or we can use potassium permanganate like this also again. Okay, that is not a problem. Now what is my question here? Select racemic compounds. Now what are racemic compounds? What about F? Yes, F is racemic mixture. What about G? Where is compound G? Yes, this is compound G. Compound G is also racemic mixture. Compound H. What is compound H? Yes, this is compound H. Compound H is also a racemic mixture. Next one is compound J. What is compound J? Okay, this okay. This is alcoholic OH. Alcoholic OH के बाद we are getting compound J. This is compound J beta, right? This is compound J. Okay, compound J treated with KBNO4. Next one is compound J treated with KMnO4 and base followed by heating and H3O plus. We are getting compound L. What is compound J? Compound J is not any racemic mixture. Okay. Now, just to change this reagent. Okay, what is actual question? Compound B से हमारे लिए चाहिए टोलिन, इनके लिए चाहिए reagent K. What is K? K is nickel, platinum, palladium or sulfur. Okay, this is compound K. Okay, right. Now what is the degree of unsaturation of compound L? Okay, this is compound L. Compound L degree of unsaturation. Okay, this is also compound here. Here benzene has 3 pi bonds, 1 ring, plus in carboxylic acid also 1 pi bond is present. Therefore, degree of unsaturation is sum of pi bonds and number of rings. Therefore, answer will be 5. Okay. Next. I think it is over, right?